when we think about data processing reference architectures, last module we covered batch processing. So in this module, we're going to look at the real-time processing reference architectures.
Yeah, definitely. It's the same vibe as module 2, but specifically looking, as you say, at real time. That sums this module really, really nicely. So,
which means we're going to be covering different methods of ingesting, working with real-time data.
Exactly.
That goes back into the mindset of event hubs, IoT hubs,
exactly.
Potentially things like streaming, pretty much.
But we do go back with lesson 1, talking about Lambda architectures again, but this time the focus is on a real-time mode.
Okay.
Yeah, and then we look at 3 examples of real-time Lambda architectures. The first example is architecting a stream processing pipeline with Azure Stream Analytics. Then we'll look at how we can design a stream processing pipeline with Azure Databricks.
Yep.
And then we acknowledge that IoT is becoming a more common reference architecture, and we'll look at an example of that. So you can make the distinction.
Which has to do with things like device management and servicing and so on.
Exactly. Okay. So like with module 2, with module 3, what you're doing is you're talking about Lambda architectures, but this time put the focus on the bottom part of the diagram, the speed layer, right? The real-time views and how you can query that. It's worth noting again that we are exposing the students to examples. We're not really asking them to answer much questions here. You're educating them about some of the architectures that we've worked with some customers here at Microsoft.
And I assume the questions would then come as part of the lab where they have to go design.
Yeah, basically.
Okay.
Basically.
Perfect.
So we look at a stream processing pipeline, this time looking at Azure Stream Analytics. Now this is actually from an open data source example, which is very famous.
That to me sounds like New York Taxi.
That is exactly what we're looking at here.
Wow, that was, I should have put money on that one.
Yeah, but it is a very, very useful example because what it's doing here, it's looking at how fare data and trip data can be separate data sources, basically, because they're coming from they're coming from separate sources, being ingested through event hubs and being brought together through stream analytics. Now, that aggregation to data that's summarized is then placed into Cosmos DB.
Why
would you do
Cosmos
that?
DB? Why not SQL database?
That could be a valid architecture choice to use, It really depends back to module 1, you know, the 4 areas of great architectures. So that will come under maybe performance, right?
Okay.
So with New York Taxis, having a SQL database in New York, in a data center near New York, actually could be very valid. But consider an example, let's say that this was for a global airline business.
Makes sense.
You see? So what you're saying there raises a really good discussion point that you can have with the
global
students.
Distribution.
Exactly. Global distribution versus local distribution.
And multi-massive to that perspective.
And you can talk about Power BI from the perspective of having real-life dashboards versus batch dashboards as well. So there's nothing stopping you from having Power BI where parts of the Power BI dashboard are being fed directly from Stream Analytics. And parts are with the aggregator from Cosmos.
So I remember one of the projects that I worked on where they were struggling implementing real-time dashboard in order to reflect store sales. I did a prototype on how to do a real-time dashboard with Power BI.
Oh, nice.
Where the pilot project that they were working on was struggling for the past 3 months.
Right.
Within an hour and 30 minutes, there we went with Power BI, real-time reporting, because of the stream analytics and then the throughput that it gives to Power BI.
Exactly. So, you know, this is the first hint really where you can talk about a true Lambda architecture using the live data from Stream Analytics and also the aggregated data from Cosmos DB.
And I think as a trainer, it's important to really look at this and go and say, hey, this is a proposed architecture. There are different ways, different flavors. The opportunity you really have there as a trainer, I think, is to bring that envisioning and that enable that thinking within your students.
Exactly. No, and that's what you're doing. You're kind of instigating inspiration in what they can do here. Now, at the bottom, you'll notice there's monitor and a dashboard, which is really introducing the notion that you can use logging technologies such as Azure Monitor as a basis to keep an eye on the performance, keep an eye on the behavior of your systems and view that information on a dashboard as well. So we're starting to tee you up really for a later module by introducing this into the architectures.
Okay.
So that's an example with Stream Analytics. The same example from a business perspective looks slightly different when you're streaming with Azure Databricks. It's different from the perspective that we have a different processing technology. The ingestion's the same. We're using event hubs, right? But event hubs can be consumed by Azure Databricks. But notice here, within Azure Databricks, it's consuming a third data source.
Interesting.
Neighborhood data. Maybe that's open source
Where
data.
does that one come from? How do you ingest it?
So the ingestion could be done through Data Factory is one example. Or it could be just simply a pull that you have through Databricks. You're literally reading data that's dropped into a file system, maybe data lake. There's a number of choices, but again, it goes back to the point, right? There's no right or wrong answers. They are merely discussion points, and there are pros and cons to each of your design architecture choice. So from here, what you're doing is you're having the data brought together, not just with the fair data and the trip data that's coming through event hubs, but that's also being amalgamated with neighborhood data. And I know of an organization near where I live that actually does this, not necessarily with fairs, but they are using neighborhood data to help them with their analytics.
Very common in real estate as well.
Exactly. So from that, you can basically do the analyzing and reporting through a bespoke application that you create. It doesn't have to be Power BI. And there you could consume the streaming data from Azure Databricks directly. You could also take the aggregated data, store that off into Cosmos DB, again having discussions about global versus local that we had in the previous slide, and then present that as streaming data in the application or batch data in the application as well.
I do want to re-emphasize though the real-time dashboarding in Power BI is really exceptional and phenomenal.
It is really
because you're
good.
literally pushing the data to the dashboard.
Exactly. But we're acknowledging here that you may have bespoke applications, your own custom .NET applications that you may want to make use of as well. And of course, we've got monitoring with Azure Monitor, keeping an eye on Databricks through a dashboard.
Okay, somehow I have the feeling that like what you did in last module, you're gonna like blow me away with a very overwhelming architectural slide. Is that the case in this module as well?
Yes, it is.
Okay.
It is. So
just to set some, there we go. Just to set some expectations on this, because that's where again we could probably see like how do I even start presenting on this or talk about this, right?
Well, first of all, let's just say that this is not an exam requirement, right? And we're looking at doing probably materials on IoTs in separate courses. The whole point of showing you this architecture really is to make the distinction between the IoT hub and event hubs, right? So what you'll see is essentially on the left-hand side, devices. Right, so there's some kind of device generating some data in some way. Maybe it's a utility company. Maybe it's a
smart monitoring,
that kind of thing. And device management is handled with the communications to the cloud gateway and the IoT hub, and that is the key distinction, right? There's two-way communication.
Maybe there's a potential subscription model for my AdventureWorks bicycle company, right, where they put sensors on the bikes.
You'd have to look at the case study to pick that out, see if that's in there. And it's worth mentioning about the case study. You know, there are things in the case study that you may completely ignore simply because it's the AI engineering course's job, or the data scientists, right?
Fair enough.
But what we've got here is the IoT edge devices, the IoT device that's connecting up to the IoT hub through a cloud gateway, and then from this, Stream Analytics is pulling data from IoT hubs.
Which is very similar to pulling it from Event Hubs.
Exactly. But what we're saying is that you're making the distinction that Event Hubs is one-way communication. It uses token management for security. With IoT hubs, it's two-way communication where you can push things to device management and so forth.
And then we got a hot path, cold path with regards to data storage.
Exactly. So basically, from the cloud gateway, you may have data going directly into Stream Analytics, or you may use Azure Functions to do simple transformations before it goes into Stream Analytics. Maybe you're doing some basic normalization, filling in missing values, and you're using a function to do it. You're storing that transformed data in Cosmos DB, so it's persisted because it isn't persisted at this point. And the cold path is outputting the aggregated data from Cosmos DB or from Stream Analytics where it can sit at rest. Why would you want to do that? It provides the input to a machine learning model. Why would we do that? Maybe you're looking for anomalies of data points from your IoT devices. Think about it. If you've got a utility pipe and different sensors at different parts of the pipe is telling you about the flows through it, maybe you can use machine learning to detect anomalies that can help with predictive maintenance solutions. As a data engineer, you don't worry about building a machine learning model, but you would certainly be bothered about provisioning this blob storage,
where to store
the Cosmos DB, the Stream Analytics, So this is why we're showing you this. Again, it's that holistic viewpoint of an overall IoT solution and how you fit into that.
So then what do we do in the lab?
Well, in the lab, what we're going to do is look at the case study from a real-time processing referencing point of view. And basically, we're going to do that from the perspective of Stream Analytics and Databricks along the business requirements. There's also, you'll notice, an attempt to design an IoT architecture.
Fair point,
because we haven't really gone into it. I think what we're looking for in this lab is, are they making the distinction? Can they spot an IoT opportunity
versus a pure data-driven opportunity?
Exactly. So the scenario gives you a little bit more context in conjunction with the case study. And what you're going to do is you're going to be able to architect stream processing pipeline with Stream Analytics, with Azure Databricks, and then identify and create an Azure IoT reference architecture.
Okay, and then you got to review the outcome again.
Review the architectures again, right? So theoretically, you're going to have three, aren't you? So if you've got two groups, look, you know how to manage a classroom. I'm not going to go into that, right? But the reason we've got 30 minutes is so you've got the time.
So how does this work, Chris? I take the students, tell them, go do this exercise. Their whiteboarding discussions, I think that's a very vivid operation. Then you're going to come back, have them present their solution, and then see what they come up with. There might be different ideas. You're going to say like, this is a feasible, reasonable solution. I assume there's a proposed solution as well.
In the download center, there are instructor notes for each lab that is done, which has a proposed solution and directions on how you should direct the group in this area. We're not leaving you hanging out to dry. Right? We've got that. We've got you covered there.
Makes sense.
As a review, go through what you've just covered. And again, we're pointing them to the reference architecture site, but this time ask them to look for real-time example reference architectures.
Perfect.
So so that's really where we come to the end of day one, where really you've showed them how to architect great Azure architectures, but you've exposed them to batch mode processing architectures real time, and they've got labs and hands-on, and they've started to design these.
Perfect. Okay, I think that was it for this module then.